Here are some examples with binomial distributions. Here's our first easy example using the binomial distribution. If x is distributed binomially with 5, 0.6, you have to remember that this 5 is n, the number of trials, and 0.6 is the probability of success, p. Find the probability that x equals 4. X equals 4 is our x. That's the number of successes we want. First, write your formula. NCXP to the xq to the n minus x. Then it's just a matter of plugging and chugging. This is, well, I know n is, I have 5 trials, combination x. Well, I want the number of successes to be 4. Whatever is there is going to go as the exponent. 4 is there, so it's going to go 4. The exponent of my probability of success, 0.6. Well, if the probability of success is 0.6, then the probability of failure is 1 minus 0.6, or 0.4. And what's the exponent there? It's going to be 5 minus 4 is 1. Notice 4 and 1 add up to 5. That's always going to be the case. Well, when I do this, remember that this is going to be 5C4 is 5, exclamation point, which is factorial, 5 minus 4 factorial, 4 factorial, times 0.6 to the 4th times 0.4 to the 1, and when you plug and chug, you get 0.26. Here is a great example using Bernoulli trials or the binomial distribution. Here, I'll read it for you. A manufacturer finds that 30% of the items produced from one of the assembly lines are defective. During this floor inspection, the manufacturer selects 6 items. We're going to take 6 from the assembly line. Find the probability that 2 are defective. Well, one of the keys to the problem is recognizing we have a binomial distribution. We either have defective or non-defective. So defective or okay, we'll say. If it's 30% are defective, let's define this as P. So if we find a defective item, then we have success. I know it's a strange way to think about it, but 30% represents our chances of success. And we're going to select 6. So that is n, the total number we're going to select. And we want to know what's the probability that 2 are defective. So that's x. I know that it's NCXP to the xq to the n minus x. I recognize I either have defective or okay, so it's a binomial distribution. The number of trials is 6, and I want to choose 2 of them, and it's going to be probability of success. Its probability of finding a defective is 0.30. Whatever is there goes here. Well, if it's 0.3 success, it must be 1 minus 0.3 or 0.70 chance of failure. 6 minus 2 is 4. Notice 2 and 4 add up to 6, so I've done it right. Well, what is the total probability then? It's, when I do this all out, it's 0.32. I've got about a 32% chance of finding exactly 2 defectives, provided that my defectives are right at 30%. Let's do this same problem again. A manufacturer finds that 30% of items produced are defective. So 30% is your P. During the floor inspection, they select 6 items, so that's your N. Find the probability that, now I change the problem, say at least 2 are defective. So, again, this is my N and this is my P, and I want an X of at least 2. So it's going to be 6C2 of 0.3, which is my probability of success, to the 2, and 0.7 to the 4. 4 and 2 make 6, or 6 minus 2 is 4. That's the probability of finding exactly 2 items defective. But now I want at least 2. So I have to add that to the probability of finding 3 defective. So that would be 6 combination 3 of 0.3 to the, whatever's there goes there, and this is 0.7 to the 3, which is 6 minus 3 there. Well, that's exactly 3. Let's add this to 6C4 of 0.3 to the 4, 0.7 to the 6 minus 4 is 2. This is the probability of finding exactly 4 defective. Plus the probability of finding exactly 5 defective is 6C5 of 0.3 to the 5, whatever's there goes there, and 0.7 to the 1. And finally, we're going to add all of that to 6C6 of 0.3 to the 6, 0.7 to the 6 minus 6, which is 0. And this gives, when you do all of this out, find this plus this plus this plus this plus this, you get 0.58, which is higher than what we found before, which was 0.32. Because now we're saying at least 2. So we have possibility of finding exactly 2, exactly 3, exactly 4, exactly 5, or exactly 6 defective. And again, the key to this problem is saying that finding a defective item is our probability of success, even though we wouldn't feel so successful finding defective items, I know. Sophie has 10 pots labeled 1 through 10. Each pot is identical. Sophie plants a seed in each pot in such a way that each seed has a germinating probability of 0.8, or 80% probability. What is the probability that all seeds germinate? Well, first we have to recognize that this is a Bernoulli trial. This is a binomial distribution, because we can define 0.8 as P. This is the probability that we're going to have success, which means that the probability of having failure is 0.2, which is Q. Well, we know that our formula is, we're going to have a C in the middle. It's going to be NCX P to the X Q to the N minus X. Well, we want to know what's the probability that all 10 seeds germinate. Well, we're going to have 10 C10. 10 trials, 10 germinate. All probability of success is 0.8 to the 10. Whatever's there goes there. And 0.2 is your probability of failure. That'll be 10 minus 10, which is 0. This works out to 0.107, which is about 11% or 0.11. This is our probability. You could keep it like that because that's 3 sig figs. This is our probability that all 10 germinate. 10C10. Continuing on here with Sophie and her plants, we have now the question is, what is the probability that only 3 seeds will not germinate? Please read the question carefully. Well, if 3 seeds will not germinate, that means that 7 do germinate. And if we define P as the probability that they do germinate, that means we're going to have 10 trials, we have 10 different pots, and we're going to select 7 for them to germinate, because only 3 do not germinate, that means 7 germinate. Well, that means probability of success remains 0.8, and that probability of failure is 0.2. 7 is there, 7 goes here. 10 minus 7 is 3. So in total, when I do this all out, I get about 0.20, about 20%. Again, we're talking about Sophie, and our third question here is, what is the probability that more than 8, so that's greater than 8 seeds germinate? Well, what does that define as? Well, we could have 9 seeds germinate or 10 seeds germinate. Well, what is the probability that exactly 9 seeds germinate? I have n of 10 selecting 9. Well, my probability of success is 0.8 and my probability of failure is 0.2. Whatever goes there is there. 10 minus 9 is 1. That's the probability of getting exactly 9 to germinate, plus the probability of getting 10 to germinate is 10C10 of 0.8 to the 10, 0.2 to the 10 minus 10, which is 0. If I find out the probability of this and I add the probability of that using my math skills, I get about 0.38 or 38% chance of getting 9 or 10 of them to germinate.